Welcome. Today we will see numericals on series programming and general programming. Now example 1 in case of series programming. The motion of a driverless vehicle which follows a wire embedded in the floor described by the differential equation yt is equal to 2 into d plus 5 into f of t divided by d plus 2 into d plus 3. Determine the computer diagram and state space representation. Now solution here yt is equal to 2 into bracket d plus 5 divided by d plus 2 into d plus 3 into f of 2. We have general nth order differential equation as d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 plus dot plus an into yt is equal to b1 d raised to n minus 1 plus b2 d raised to n minus 2 plus dot plus bn into f of t, which is in the matrix form as. Therefore matrix form of the above equation is x1 dot x2 dot x3 dot xn dot is equal to minus a1 1 0 0 minus a2 0 1 0 minus a3 0 0 1 dot minus an 0 0 0 into x1 x2 x3 dot xn plus b1 b2 b3 dot bn into f of t and yt is equal to x1. Therefore we have d plus 2 into d plus 3 into yt is equal to 2 into bracket d plus 5 into f of t. Therefore d square plus 5d plus 6 into yt is equal to 2d plus 10 into f of t. Therefore comparing with standard form with this equation, we are getting a0 is equal to 1, a1 is equal to 5, a2 is equal to 6 and b1 is equal to 2, b2 is equal to 10. Therefore x1 dot upon x1 dot x2 dot is equal to minus a1 1 minus a2 0 x1 x2 plus b1 b2 into f of t. Therefore substituting the values in the matrix, x1 dot x2 dot is equal to matrix of minus 5 1 minus 6 0 x1 x2 plus matrix of 2 10 into f of t. Therefore from this matrix we are getting the values of x1 dot is equal to minus 5x1 plus x2 plus 2f of t and x2 dot is equal to minus 6x1 plus 0x2 plus 10f of t, that is minus 6x1 plus 10f of t, and yt is equal to x1. Therefore we will represent these three equations by using computer diagram. At last our output yt should be equal to x1. Therefore first of all ft 10 ft, again it is fed back to this summing point. After summing point output is x2 dot, integration of x2 dot is x2, again it is fed back to this summing point. Again output of from this summing point is x1 dot, integration of x1 dot is x1, output is yt, therefore yt is equal to x1. Now x2 dot is equal to 10 ft minus 6x1, therefore from this x1 we have to take one signal it and x1 into this transfer function 6, that is 6x1, its signal is negative, therefore x2 dot is equal to 10 ft minus 6x1. And again here x1 dot is equal to 2ft plus x2, therefore here that value is there, x1 dot is equal to minus 5x1 plus x2 plus 2ft. Therefore x1 dot is equal to minus 5x1 means again from this takeoff point we have to give transfer function 5, its signal is negative, therefore minus 5x1 plus x2 is already there, x2 signal, and plus 2ft. From this ft we have to take off signal and we have to multiply it by 2. it we have to fade back to this summing point. Therefore x1 dot is equal to 2 of t minus 5x1 plus x2. Therefore this is nothing but computer diagram. Now second example, the speed of an automobile which is being controlled by the cruise control is described by the differential equation yt is equal to 2 into d plus 5 divided by d plus 2 into d plus 3 into d plus 4 into f of t. Determine the computer diagram and state space representation by series programming. Therefore here yt into d plus 2 into d plus 3 into d plus 4 is equal to 2 into d plus 5 into f of t. Therefore yt into d square plus 5d plus 6 into d plus 4 is equal to 2d plus 10 into f of t. Therefore d cube plus 4d square plus 5d square plus 20d plus 6d plus 24 into yt is equal to 2d plus 10 into f of t. Therefore d cube plus 9d square plus 26d plus 24 into yt is equal to 2d plus 10 into y of t. Therefore comparing this equation with standard form, we have now this matrix form is there. x1 dot x2 dot x3 dot is equal to minus a1 1 0 minus a2 0 1 minus a3 0 0 into x1 x2 x3 plus b1 b2 b3 into f of t. Therefore x1 dot x2 dot x3 dot is equal to minus 9 1 0 minus 26 0 1 minus 24 0 0 into x1 x2 x3 plus 0 to 10 into f of t. Therefore x1 dot is equal to minus 9 x1 plus x2. x1 dot is equal to minus 9 x1 plus x2 because 0x and 0 ft they are having 0 values. x2 dot is equal to, directly we will write minus 26 x1 plus x3 plus 2f of t. x2 value is 0. x3 dot is equal to minus 24 x1 plus 10 f of t, and yt is equal to x1. Therefore these four equations we will represent by using computer diagram. Therefore this is our computer diagram. First f of t 10 x3 dot is equal to, what is x3 dot is equal to minus 24 x1 plus 10 f of t. Therefore x3 dot 10 f of t minus here x1 24 x1. Therefore x3 dot integration of x3 dot is equal to x3, again it is fed back to the summing point x2 dot. Therefore integration of x2 dot is equal to x2 and integration of, again it is fed back to the summing point. From summing point output signal is x1 dot, its integration is x1. Therefore y of t is equal to x1. Therefore from this x1 we have taken one takeoff signal. It's we have fed back to this 24 element and we have fed back to this summing point having negative value. Therefore x3 dot we are getting it as 10 ft minus 24 x1. Similarly x2 dot is equal to 2 ft. Therefore from this f of t signal we have to take one signal and we have to give it to feedback element 2. Therefore 2 of f of t, its value is positive. Therefore x2 dot is equal to 2 ft minus 26 x1. Therefore again from this x1 we have to take another signal and we have to feed back to this 26, and again from 26 that signal goes to this summing point, its signal is negative. Therefore x2 dot is equal to minus 2 ft minus 26 x1. Similarly x1 dot is equal to minus 9 x1 plus x2, minus 9 x1 plus x2. Therefore already this x2 signal is there, x2 its value is positive or signal is positive. Therefore again from x1 we have to take this another signal, we have to feed back to this transfer function having value 9. Again we have to feed back to this summing point having negative signal. Therefore x1 dot is equal to minus 9 x1 plus x2. Therefore this is the computer diagram. Now example 3. Determine the state space representation using series programming and draw the computer diagram for the system with yt is equal to 2d square plus 6 into f of t divided by d plus 1 into 2d plus 1 into 3d plus 2. Therefore, solution here yt is equal to 2d square plus 6 into f of t divided by d plus 1 into 2d plus 1 into 3d plus 2. Therefore, d plus 3 into 2d plus 1 into 3d plus 2 into yt is equal to 2d square plus 6 into f of t. Therefore, 2d square plus d plus 6d plus 3 into 3d plus 2 into yt is equal to 2d square plus 6 into f of t. Therefore, 6d cube plus 4d square plus 3d square plus 2d plus 18d square plus 12d plus 9d plus 6 into yt is equal to 2d square plus 6 into f of t. Therefore, 6d cube plus 25d square plus 23d plus 6 into y of t is equal to 2d square plus 6 into f of t. Now comparing with standard equation form, we have a naught is equal to 6, a1 is equal to 25, a2 is equal to 23, a3 is equal to 6, and b1 is equal to 2, b2 is equal to 0, and b3 is equal to 6. Therefore, we will substitute this value in our standard matrix form. x1 dot x2 dot x3 dot is equal to minus a1 1 0 minus a2 0 1 minus a3 0 0 x1 x2 x3 plus b1 b2 b3 into f of t. Therefore, x1 dot x2 dot x3 dot is equal to matrix of minus 25 1 0 minus 23 0 1 minus 6 0 0 into x1 x2 x3 plus 2 0 6 into f of t. Therefore, from this matrix we will find out values of x1 dot x2 dot and x3 dot. Therefore, x1 dot is equal to minus 25 x1 plus x2 plus 2 f of t. x2 dot is equal to minus 23 x1 plus x3. x3 dot is equal to minus 6 x1 plus 6 f of t, and yt is equal to x1. Therefore, yt is equal to x1. Directly this output is there. First of all, we will see the computer diagram f of t. First of all, x3 dot is equal to minus 6 x1 plus 6 f of t. Therefore, from this summing point x3 dot, its value should be 6 f of t minus 6 x1. Therefore, x3 dot, integration of x3 dot is x3. Again, it is fed back to the summing point. From the summing point x2 dot signal is there. Therefore, x2 dot, its integration is x2. x2 again is fed back to the summing point. Again, x1 dot signal, output signal from the summing point, its integration is x1. Like this forward path we have seen. Again, we see now backward path from this equation. First of all, we will see x3 is equal to minus 6 x1 plus 6 ft. Already 6 ft is there. Therefore, we will take signal from here x1, and this 6 is multiplied by x1. Therefore, 6 x1 and its signal is negative here. Similarly, x2 dot is equal to minus 23 x1 plus x3. Therefore, x2 dot is equal to plus x3 is already there, and only minus 23 we have to add. Therefore, again we have to take signal from x1 here, x1 line. We have to add a block having minus 23. Therefore, minus 23 x1 we have to feed back. Now, x1 dot is equal to minus 25 x1 plus x2 plus 2 ft. Therefore, x1 dot is equal to x2 is already there. Therefore, only minus 25 signal we have to take 25. Its signal is negative, minus 25 x1 plus x2 is already there, plus only 2 ft. Therefore, from ft we have to take one signal, and we have to add a block of 2, and we have to feed back to this summing point. Its value is positive. Therefore, this completes our computer diagram. Now, up till now we have seen problems on direct programming, parallel programming, and series programming, and now last point is there, that is general programming. Problems on general programming. Therefore, examples on general programming we will see now. Example 1. The motion of a driverless vehicle which follows a wire embedded in the floor is described by the differential equation yt is equal to 2 into d plus 5 divided by d plus 2 into d plus 5 into f of t. Determine the computer diagram and state space representation by general programming. Therefore, solution here yt is equal to 2 into d plus 5 divided by d plus 2 into d plus 5 into f of t. Therefore, general form of differential equation for general programming is d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 plus dot 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 plus an into y of t is equal to b naught d raised to n plus b1 d raised to n minus 1 plus b2 d raised to n minus 2 plus dot 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 plus bn into f of t. Therefore, now then the matrix form is given by x1 dot x2 dot 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 xn dot is equal to 0 1 0 dash 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 0 0 0 1 0 then dash 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 minus an minus 1 minus an minus 2 dash 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 minus a1 into x1 x2 dot 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 xn plus h1 h2 dot 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 hn into f of t. Therefore, where h1 is equal to b1 minus a1 b naught, h2 is equal to b2 minus a2 b naught minus a1 h1, h3 is equal to b3 minus a3 b naught minus a2 h1 minus a1 h2, hn is equal to bn minus an b naught minus an minus 1 h1 minus an minus 2 h2 minus dot 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 minus a1 hn minus 1. These are the standard equations. These are standard equations of this method. Therefore, we have d plus 2 into d plus 3 into yt is equal to 2 into d plus 5 into f of t. Therefore, d square plus 5d plus 6 into yt is equal to 2d plus 10 into f of t. Therefore, comparing with standard form, a0 is equal to 1, a1 is equal to 5, a2 is equal to 6, b0 is equal to 0, b1 is equal to 2, b2 is equal to 10. Therefore, we will substitute these values in matrix form. Therefore, x1 dot x2 dot is equal to 0 1 minus a2 minus a1 x1 x2 plus h1 h2 into f of t. Therefore, h1 h2 is equal to b1 minus a1 b0 which is equal to 2 minus 1 into 0 which is equal to h2 is equal to b2 minus a2 b0 minus a1 h1. These are the standard equations of h1 h2. Therefore, h2 is equal to 10 minus 6 into 0 minus 5 into 2. Therefore, h2 is equal to 0. Therefore, x1 dot x2 dot is equal to, we will substitute the values now, 0 1 minus 6 minus 5 x1 x2 plus 2 0 f of t. Therefore, x1 dot is equal to x2 plus 2 f of t. x2 dot is equal to minus 6 x1 minus 5 x2 plus 0 f of t, and yt is equal to x1 plus b0 of ft, that is, since b0 is equal to 0, yt is equal to x1. Now we will represent these three equations by using computer diagram x1 dot x2 dot and yt. Therefore, computer diagram is f of t x2 dot is equal to, see that x2 dot is minus 6 x1 minus 5 x2, 0 f of t. Therefore, this f of t signal will put here transfer function having block having its value 0. Therefore, x2 dot is equal to x2 dot, its integration is x2, again it is fed back to the same point, x1 dot output is here, then integration is there, then x1 is here, then y of t is equal to x1. Therefore, from x1 we have taken one signal, its value is, we have to add a block of 6, its sign is negative. Therefore, x2 dot is equal to minus 6 x1. Again, from x2 we have to take one signal and we have to multiply it by the block having value 5. Again, its signal is negative. Therefore, x2 dot is equal to minus 6 x1 minus 5 x2. Here again, x2 dot x1 dot is equal to x2 plus 2 of f of t. See that x2 plus 2 f of t. Therefore, x2. Therefore, from f of t we have to take another signal and we have to add a block having its value as 2. We have to fed back to the same point having the signal positive. Therefore, this completes your computer diagram. Now, next problem. Determine the state space representation using general programming and draw computer diagram for a system with yt is equal to 2d square plus 6 divided by d plus 3 into 2d plus 1 into 3d plus 2 into f of t. Therefore, yt is equal to 2d square plus 6 divided by d plus 3 into 2d plus 1 into 3d plus 2 into f of t. Therefore, d plus 3 into 2d plus 1 into 3d plus 2 into yt is equal to 2d square plus 6 into f of t. Therefore, 2d square plus d plus 6d plus 3 into 3d plus 2 into yt is equal to 2d square plus 6 into f of t. Therefore, 6d cube plus 4d square plus 3d square plus 2d plus 18d square plus 12d plus 9d plus 6 into yt is equal to 2d square plus 6 into f of t. Therefore 6d cube plus 25d square plus 23d plus 6 into y of t is equal to 2d square plus 6 into f of t. Therefore, comparing this equation with standard form, we have a naught is equal to 6, a1 is equal to 25, a2 is equal to 23, a3 is equal to 6, b0 is equal to 0, b1 is equal to 2, b2 is equal to 0, b3 is equal to 6. Therefore, putting this in matrix form, we have x1 dot x2 dot x3 dot is equal to 0 1 0 0 0 1 minus a3 minus a2 minus 1 minus a1 x1 x2 x3 plus h1 h2 h3 h3 into f of t. Now h1 is equal to b1 minus a1 b0, therefore substitute the values. H1 is equal to 2 minus 25 into 0, which is equal to 2. H2 is equal to b2 minus a2 b0 minus a1 h1, therefore h2 is equal to 0 minus 23 into 0 minus 25 into 2, therefore h2 is equal to minus 50, and h3 is equal to b3 minus a3 b0 minus a2 h1, which is equal to 6 minus 6 into 0 minus 23 into 2, therefore h3 is equal to minus 40. Therefore x1 dot x2 dot x3 dot is equal to 0 1 0 0 0 1. We have to substitute the values. Minus 6 minus 23 minus 25, x1 x2 x3 plus 2 minus 50 minus 40 into f of t. Therefore x1 dot is equal to x2 plus 2 ft, x2 dot is equal to x3 minus 50 ft, and x3 dot is equal to minus 6 x1 minus 23 x2 minus 25 x3 minus 40 ft, and yt is equal to x1 plus b0 of ft. Since b0 is equal to 0, yt is equal to x1. Therefore our computer diagram is like this. Y of t, this is yt output. F of t, transfer function for t, this fed back to the signal, summing point. Therefore x3 dot, integration of x3 dot is x3, again this fed back to the summing point. Output is x2 dot, integration of x2 dot is x2, again it is fed back to the summing point. Again x1 dot, integration of x1 dot is x1, therefore y of t is equal to x1. And now we have to go backward. Therefore x3 dot is equal to minus 6 x1 minus 23 x2 minus 25 x3. Therefore just take out the signal and add the transfer function blocks. In the signal of x1 6, in the signal of x2 that is 23, and in the signal of x3 25. All the signals are negative here. And now x1 dot is equal to x2 plus 2 of f of t. Therefore from f t we have to take one signal, we have to add a block having its value 2. Therefore the value of that block, signal of having sign of that block is positive, feedback signal positive. Therefore x1 dot is equal to x2 plus 2 f of t. And x3, x2 dot is equal to x3, x2 dot is equal to x3 minus 50 ft, x2 dot is equal to x3 minus 50 ft. Therefore this completes our computer diagram and this completes our chapter. Thank you very much.